Okay, welcome back. We're going to run through problem 87 on page 58. This is a sister to problem 84 on the same page. And both of them say, here's a function, find the difference quotient. So I won't take too much time explaining the difference quotient. I've done that already in class. I'll likely do it more because as I've said, to me it's a little bit odd for pre-calculus to introduce this concept, but I'm glad they did because it truly is the gateway to differential calculus. But rather than go through that at the moment, let's just do this problem. This problem says write down the difference quotient for this function. And here's what you do. The difference quotient is defined to be the quantity f of x plus h minus f of x divided by h. That's the difference quotient. It also happens to be, and it's important for you to remember this connection, it happens to be the average value, or sorry, the average rate of change of the function f of x over the interval from x to x plus h. Okay, so geometrically, that's what this quantity is. All you need to do in this problem is to calculate f of x plus h. When you do that, all you have to do is insert x plus h every place you see an x here. So it's 2x plus h all over x plus h plus 3. And then write down f of x. There it is. 2x over x plus h, and then form this this difference quotient, right? It's f of x plus h, this quantity, subtracting this quantity, and the whole thing divided by h. So I've got to tell you, that's the answer. And in fact, I think I'm going to leave the answer like this. It's kind of a nasty thing to do. But if I was to reduce this problem, and I believe it reduces to this, believe when you actually do the manipulations, you end up with x plus 3 plus h times x plus 3 all dividing into 6. But that's just simple algebra. The heart of this problem is to know what this definition is, to know what the geometrically what it means, and then just to be able to kind of set it up in this way. All right, good enough.